students, welcome to the next lecture of subject measurement and instrumentation. During the last lecture, we have learned about what is measurement, the significance of measurement, and then we have seen what are the two methods of measurement, direct method of measurement and indirect method of measurement. And finally, we have discussed with the help of a block diagram the generalized elements of the measuring system. Okay, so in this first unit, the next part what we are going to learn is performance characteristics of the instruments. Okay, so as you see here, the performance characteristics is of two different types. The two basic characteristics are, one is said to be as a static characteristics and another as a dynamic characteristics. Okay, now what are the different static characteristics that we are going to see along with their terms as a definition, and then we will see what are the dynamic characteristics along with the terms as a definition. Okay, so as you see here, the various different static characteristics are as summarized over here. The static characteristics are, one is accuracy, second is precision, third is resolution, fourth is sensitivity, and fifth one is an error. Okay, here you can also say it as a static error. Now let us see what are these static characteristics that an instrument can possess. Okay, so the first characteristics, as you see, accuracy. So what is meant by accuracy? So by definition it has been said that it is the degree of exactness or closeness with which a measured value approaches the true value. Okay, so here if you can elaborate this particular point, what we can say is, what is meant by true value? True value is nothing but the actual value of the unknown quantity, okay, that we are going to measure. And measured value is what? It is the value that is being shown by the measuring instrument or a measuring system. So suppose if there is a difference in the value what we call as a true value and the value that is being shown by the measuring system, there is a small difference in it. Okay, now whatever this difference is there, that is going to be measured as a accuracy of that particular instrument. Okay, now if suppose here the true value is for a particular parameter, like we are measuring the EMF, if it is suppose 5.2 volts, then if the measured value is 5.19 or 5.21, means that particular instrument is said to be as accurate. Okay, so how closely that particular measured value is near the true value, that closeness or exactness is nothing but the accuracy. So as far as considered, every instrument should be of a high accuracy. That means the value shown by the measuring instrument should be very close or near to the actual or true value of the unknown parameter. Okay, so that's what is our accuracy. One more characteristic is precision. What is precision? It is the measure of the consistency or repeatability of measurements. That is, successive reading do not differ from one another. Now what it means? It means that suppose you are using a voltmeter to measure a EMF of a battery. Okay, now at a particular time of a day, suppose in the morning 9 o'clock, you have measured the EMF of that battery. Okay, without using it at the idle state, we are measuring just what is the EMF of the battery. So you will find that EMF of the battery is 12.4 volts. Okay, after a particular time, after 2 hours, means at again 11 AM in the morning, you are measuring the EMF of the battery you will find that now it is 10.41 volts. Okay. Now again after a few hours, if you again measure it, now it will show 4.38. Means what? Here what is happening? The battery is same, the measuring instrument is same, but at different time when you are consecutively checking the voltage, you find that these values are not exactly same. Initially it is 12.4, then it becomes 12.42, then it becomes 12.39. Likewise, means if suppose after a repeated or successive reading, if those values that you are measuring is very close to each other, we will call that the instrument is precise or it is having good precision. But if the values shown by that particular measuring instrument at different times successively, if it is differing with a very higher value, then you can say it is having low precision. Okay, so as far as considered, instrument should have a good precision. That means if you are measuring a particular parameter, even after successive readings, after repeated readings, the values what will be shown by that instrument should be near to each other, that is very close to each other or same. Okay, so that's what about the precision. Next one, the characteristics is resolution. Resolution, what it is? It is the smallest change in the measured value to which a measurement system will respond. Means, suppose you are using a particular voltmeter, and if the voltage whatever changes that are taking place are of a very small value, then for that smallest change in the actual voltage, that particular measuring instrument or a voltmeter should respond. Okay, but if even though there is a change in the actual value, if that particular measuring instrument doesn't changes its value, then we can say that it is having low resolution. Means for a particular instrument, the resolution should be as high as possible. Means what? Even though the voltage, suppose we are measuring, is changing with a slight value, millivolts or even a few volts, then also that measuring instrument should show that smallest change also. If it is showing so, then we can say it is of good resolution. Okay. Next one is a sensitivity. Now what it is? It is the ratio of output or change in response of a measurement system to the change in input or measured variable. So what it is? It is a ratio. Ratio of what? Output to the input, or you can say it is a ratio of change in output to the change in input. Now as far as considered, a particular instrument should be highly sensitive. For example, if you are having suppose a parameter measuring device, and if the parameter what you are measuring is changing drastically, then whatever changes that are taking place at the actual parameter, that should be immediately shown by the instrument. Okay, that is only possible if the sensitivity is high. But even though if a particular parameter is changing drastically, and if an instrument is not responding to that particular changes, then we can say that the instrument is of low sensitivity. Okay. Next to that, one more static error what a particular instrument should possess is an error, or you can also call it as static error. Now what it is? It is a deviation of a true value from the desired value. It is a difference between expected value of a variable and the measured value of the variable. Means what? Suppose if you are, again let us take an example, if you are measuring a voltage with the help of a voltmeter. Now the true value of voltage is suppose 12.3 volts, and the measuring instrument is showing you only 10.1 volt. Means what is actually desired one? The desired thing was the meter should have shown 12.3, exactly same what it is actually, but the meter is not showing 12.3, it is showing 12.1. Means what? There is a difference between the actual value and the measured value. Now this difference between the actual value and the measured value, that is here in this case it is 0.2 volts, that is what we can say is an error. Now as far as considered, for a good instrument, this value of error should be as minimum as possible. Means what? The true value and the measured value, the difference between these two should be very very low. Okay, so that is what we call as a static error. Hence it is been said as it is a difference between expected value of variable and the measured value of the variable. Okay, so let us summarize once again what are the different static characteristics. The different static characteristics are accuracy, precision, resolution, sensitivity, and error. Okay, now these are what are the static characteristics. Similarly, the another type of characteristics what an instrument should possess is said to be as dynamic characteristics. Now, under dynamic characteristics, there are four characteristics. One of them is speed of response, second is fidelity, third is measuring lag, and fourth is dynamic error. Now let us see in brief what are these four dynamic characteristics. As seen here, first one is speed of response. What it is? It is the rapidity with which a measurement system responds to the changes in the measured quantity. Means what? The speed of response for a good instrument should be very quick, or it should be high as possible. Suppose if there is a quantity which is continuously changing with respect to time, and when this quantity is changing with respect to time, and if you are measuring it with an instrument, that instrument should immediately show the changes that has occurred in the actual parameter. Means suppose if a particular temperature is changing drastically from 1 second to 3 seconds, if the temperature is changing from 5 degrees to 8 degrees suppose, then within that few seconds this particular instrument should change its value from 5 degree to the 8 degrees. Now what happens is some of the instruments will have a very low speed of response. Means what? Even when the actual temperature which is changing through time has reached the higher value of about suppose 8 degrees within few seconds, suppose within 5 seconds, if the temperature is changing from a particular 5 degrees Celsius to 8 degrees Celsius, then the instrument will not show the 8 degrees Celsius within 5 seconds. It will take a certain time, and then when the actual temperature reaches 10 degrees, then it will show it is 8 degrees, and likewise. Means what? The speed of response of a particular instruments are dependent. Okay, and as far as considered, this speed of response should be quick. Means the instrument should rapidly respond to the changes in the measured quantity. Okay, now next one is fidelity. What it is? It is the degree to which a measurement system indicates changes in the measured quantity without any dynamic error. Means what? Here fidelity, suppose again let us consider that a quantity is continuously changing with time. Okay, and suppose we are having a quantity which is changing with time in form of suppose a sinusoidal waveform. Okay, now if the actual value is changing at a continuous and a constant particular frequency, suppose, then whatever changes that are taking place or shown by the measuring system should follow the same sine wave. If it is following the same graph of sine wave, then we can say that the instrument is of very good fidelity. But suppose if the instrument shows the measuring, if the measuring system or instrument shows the values which are not exactly as a sine wave, then we can say that it is of low fidelity. Means here fidelity is what? It is such a way that the measuring system should indicate all the measured quantities with the same changes that it is taking place with respect to time. Okay, means it should maintain the graph of actual changes in the quantity. Okay, so next one, the third dynamic characteristics is a measuring lag. Now what it is? It is the retardation or delay in the response of a measurement system to the changes in the measured quantity. Means what? Here again let us take one example. Suppose there is a drastic change in the temperature that is taking place, and if you are using a measuring system to measure the temperature, now what happens? The temperature has started to rise. It is rising from, suppose, let us take 15 degrees Celsius. It has started to rise. It became 16, it became 17, it became 18, it became 19. And between these changes, whatever measuring system we are using, that is not responding at all. And when the temperature has reached 19 degrees, then the measuring system has started to show the changes, and now it is showing only 16 degrees. When the temperature is at actually 23 degrees, now the measuring system is showing 19 degrees. Means what? The measuring system is not showing the actual value in time. There is a delay in the response of the measuring system. So when such a thing is happening, there will be an error that may take place, and hence as far as considered, there should be a minimum lag in a measuring system. Means what? The delay in the response of the measuring system to the changes in the measuring quantity should be as low as possible. Okay, and finally the last characteristics under dynamic characteristics is dynamic error. Now what it is? It is the difference between the true value of a quantity changing with time and the value indicated by the measuring system if no static error is assumed. So here this dynamic error is actually nothing but again same as the error, but only what here is, we are calling it as dynamic error because it is referred to a quantity which is changing with respect to time. Okay, so here again error is measured by taking the difference between the true value and the value indicated by the measuring system. But here only the difference is, here the quantity is changing with respect to time. So again what we can say, if suppose a temperature is changing with respect to time and actual change in the temperature is suppose from 15 degrees Celsius to 19 degrees Celsius. Okay, but whatever measuring system that is measuring this change in temperature is showing 15 degrees Celsius to only 16 degrees Celsius. Means what? Actual change is 15 to 17 degrees Celsius. And here the measuring system is showing 15 to 16 degrees Celsius. Means what? There is an error of 1 degree Celsius. Okay. So when we are taking the difference between the two quantities, that is true value and the measured value, here we are going to call it as dynamic error if the measured value is continuously changing with respect to time. Okay, so these are what we can say are the dynamic error. So as far as considered, the dynamic error of a particular instrument should be as low as possible. Okay, means we will call that measuring this system is a good one. Okay, so finally what we can say is there are four dynamic characteristics, and the four dynamic characteristics are speed of response, fidelity, measuring lag, and dynamic error. Okay, so that are what we can say are the performance characteristics of an instrument. So what we can summarize is the performance characteristics of instruments are classified into two groups. One is static characteristics and another is dynamic characteristics. Under static, there are five: accuracy, precision, resolution, sensitivity, then error. And under dynamic, there are four: speed of response, fidelity, measuring lag, and dynamic error. Okay, so these are what are the performance characteristics of an instrument. So with this, we are concluding our lecture here itself. Hope you all have understood this. Thank you. Thank you very much.